let's just talk about a relation. Okay? So the beginning of our notes today in your packet, it talks about a relation. And a relation is just a set of ordered pairs. I gotta fix my pen. Ordered. A relation is just a set of ordered pairs. Okay? That's all a relation is. All right, and I'm going to fix my pen, y'all. It's a little too thick. All right. So, anybody said something about a relation? That's all it is a set of ordered pairs. We can represent a set of ordered pairs 4 different ways. There's 4 major types of ways. The first one is just a listing of ordered pairs. Okay? We can put them in a table. We can do a mapping, which is basically 2 ovals, or we can graph the points. All right? So, I'm going to do the table first. So, when you make a table, it's pretty simple. X is on the left, Y is on the right. So, the first ordered pair is -3, 1. Second one's -2, 0. Then 1 and 2, and 3, -4, and -3, +5. So basically in a table, you're just separating your ordered pairs, the X's and the Y's. Okay? Y'all just fill in with me, please. All right. When you do a mapping, you basically just take your X's and Y's and put them in numerical order. Okay? So my X's go from -3, and you don't repeat them. So -3, -2, 1, and +3 are my X's in numerical order. Y'all agree? Least to greatest. And my Y's least to greatest, aren't they -4, 0, 1, 2, 5? Okay. So we're gonna show you what they do. So you don't repeat them when you do a mapping. Okay? So when you list your X's and Y's in numerical order, least to greatest. If they repeat, you leave them off, because I'm going to show you how we account for that in a mapping. Okay? Then I just like to go from my table, because to me it's easier to see my ordered pairs all spread out in the table. So -3 maps to what Y value? 1. So you're going to draw an arrow from your X to your Y value. So -3 goes to 1. Okay? -2 goes to what Y value? So you're going to draw an arrow from -2 to 0. 1 maps to what Y value? 2. 3 maps to what value? So I'm crossing over here. And then -3 also, wait. Then I also have -3 going to +5, right? So do you see how that X value has 2 branches going off of it? 1 to 1 and 1 to 5. I know that gets a little messy looking. Right? It gets messy looking. All right, but that's called a mapping. So it shows what X values go to what Y values as ordered pairs. Right? And finally, we graph it, and that just means you graph the points. And these don't have capital letters for you to label them, so you just put your dot on there and you're fine. So left 3 up 1 is -3, 1. -2, 0 is on the x-axis at -2. 1, 2 is right 1 up 2. 3, -4 is right 3 down 4. 2, 3, 4. Hopefully I counted that correctly. And then left 3 up 5. 1, 2, 3, 4, 5. Oh, that didn't go 3, did it? Go over one more. Okay, so for the graph, you just plot your points. And apparently, everything just went crazy for me for a second. I don't know what's happening, y'all. All right, so the last thing, if you see blank on that number 1, is something called the domain and range. So any questions about our table or mapping or a graph? All right, domain and range is really important, okay? So right here under the table, it says the set of X values is called the domain. So write the word domain right here. You might want to go back and highlight this later because it's really important. And does anybody know what the set of Y values is called? The range. If you can't remember what is what, they're in alphabetical order. Domain comes before range, X comes before Y in the alphabet, right? So that might help you remember it. So anytime anybody's talking about a domain, it's talking about the X values. And anytime anybody's talking about a range, it's talking about the Y values for a relation. All right? So when we list the domain and range, the domain is just the set of your X values. And y'all, this is funny. Y'all know those little curly brackets that everybody has trouble drawing? Well, they look like this or something. Yeah. So when you list your domain, you're going to do a curly bracket. All right? And then your X's go in that list in order from least to greatest, and you do not repeat. So if you did your mathing correctly, that should already be in that order and we didn't repeat, right? So my X's from least to greatest and not repeating are -3, and separate them with a comma, -2, 1, and 3, and close your bracket. Mine looked like a crazy 3, yeah. It's okay. I know what you're trying to do. And then your ranges, same thing. This time the range is what values? Y values in order from least to greatest and do not repeat. Okay, so -4 is my lowest Y value. So -4, 0, 1, 2, 5. And then I got to think about my curly brackets. So y'all, I'm not very good at them either. There you go. All right. Any questions? I want y'all to try number 3. We'll skip number 2. But look at what number 3 did to you. What'd they do? They gave you the graph. So what I would do first is I would come over here and write my ordered pairs. That's what I would do. So y'all try that. And then fill in your ordered pairs, domain and range, your table, and your mapping. And if I were you, I would do domain and range last because it's always easier for me after I do my mapping.
We just pick one. You just pick one, write down.
Yeah, it don't matter the order, really, for your table. I like to go left to right. So this one, then this one, then this one, then this one, then this one. Does that make sense?
So you can go to your real estate, you can go to your real estate, and go right and look in that spot. And you can tell them what you want. Nope, I'll go tell the call from the garbage at the door. And she's gonna say, you are exactly right. Aww. You all tell her. Very good. Cross curricular. I know what I'm doing. Do you have a paper gloss now or y'all? What's a gloss? Oh. Paper gloss is big vocabulary. Yes. A big vocabulary book. You know, when you don't know a word now, you Google it. Back when I was growing up, we had like a paper book that we had to go through. I just call the dictionary. Call the dictionary. Glossary and dictionary, the same thing. There you go.
Something that dinosaurs used long time ago.
Okay. No more English class. So no more English class. 5W squared, 96W plus 1.
What did you think about domain and range and relations, mappings and tables
You've
and
got
graphs?
half equal, -6 and multiplied equal.
I wrote my ordered pairs in my table, so y'all can look up and make sure you do that correctly, and then y'all can do your table.
All factors are negative. We only have one step to work. What is it? -1, -5. Now, what is the leading coefficient?
My X is already in order because I went left to right. See, that's another thing about going left to right if they give you the graph. Is that why your x's are already in order? Right?
Do they have to be in order?
No. I just went left to right, so mine would be.
5W squared and negative W. What's the GCF? W.
They don't have to be on the table, but they need to be on your mapping, and they need to be in your domain and range.
What's the GCF of second group? -1. Factor that out. What's left? Going to be 5W minus 1. Please don't miss that sign. Gotta be careful. At least you were erasing the top line. All right, 2 by 2 little factor. W minus 1. 5W minus 1.
All right, y'all help me. I'm going to do my mapping. What is -5 pair to? -4. Whoopsie, stop it. -5 goes to -4. -2 goes to which one? +3, which is what? Stop touching things, Mrs. School. And then 0 goes to -3. 2 goes to -5. -5. And 4 goes to 2. And what's the domain? Domain is what values? X is in order from least to greatest and do not repeat. So my mapping is correct, isn't it? -5, -2, 0, 2, 4 for the domain. And your range is what? -5, -4, -3, 2, 3. Raise your hand if you got your domain and range correct. All right, good job. All right. We're going to talk some more about domain and range. So that's what the majority of this lesson is going to be about, domain and range, and then we'll get to functions in a minute. Okay, y'all. This is to the part of the lesson that is super duper 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 important. Okay? When I say it's super duper duper extra duper important, it really is. Because like I said, you will need this information in Algebra 2, college algebra. Any math class that you take that's higher than this one, you're going to need to talk about domain and range. All right? State test and benchmark test love these questions as well. Okay? It is major content. All right? That's not me trying to scare you. That's just me trying to tell you this is how much we need to pay attention and learn this. All right. First of all, let's just fill in these blanks. Let me swap to a red pen. For a domain, now domain is what values? X values. You're going to scan your pencil from left to right. So you're looking horizontally. So you're going to go left to right to find out what X values you're including on your graph. Okay, so which X, when you scan your pencil, what is your pencil touching from left to right? Okay, that is for the domain. For the range, where do you think you're going to go? Up and down. Very good. Because you're looking at the Y values. And Y values go vertical. Okay, so for your Y values, you're going to scan your pencil up and down to see what Y values you're going to touch on your graph. Okay? All right. So let's just see examples. The best way to understand domain and range is to see a lot of examples. Okay? So they're going to give us a graph. All right? The picture is already done for us. And all we have to do is determine the domain and the range. Okay? Domain is what values? X's, range is what values? Y's. Okay, so domain we look left to right, ranges we look up and down. Okay? So, domain. This graph right here. So we're looking at the X's. So from left to right, you see how I have arrows going in both directions? Y'all see that? So that domain is going to infinity in both directions. So that is going to be all real numbers. So if it's going both ways, all directions and both ways for your domain, you're going to write all real numbers. And you can write the little hashtag sign for numbers, okay? Now the domain for number 1 is all real numbers. Because it's got arrows pointing in both directions. Left to right, it's going out forever. All right. The range, going up and down. Look right here. Start down here. I'm not touching my graph yet, am I? When I say my graph, I'm talking about the thing that's drawn on the X and Y axis, not the X and Y axis itself. Okay? So look, I'm not even touching my graph down here, right? So my range don't even start till I get to this point. Do you see that? Y'all see that? Okay? And then it looks like it's going up forever from that. Do y'all see that? Okay, so what is this number? Yeah, the Y value is -2. So for the range, since range is Y, we're going to say the range is Y values that are greater than or equal to -2. The Y values for this graph are greater than or equal to -2. Y'all understand it? So it's not all real numbers because it don't go down forever. Do you see that? It does go up forever after it gets past -2. Does that make sense? And since this is bolded, it's colored in on the graph, -2 is included. So that's why we say or equal to. Okay, so the Y values are on this graph are Y values that are greater than or equal to -2 because it's going up forever after -2. Does that make sense? All right, a circle. All right, so domain is the X's. Is the X values all real numbers? No, it's not going to forever in both directions, is it? It's actually stopping in 2 places, right? So my X values are happening between here and here. Y'all agree? Okay, what's this X value? -3. What's this X value? +3. So your X values are between -3 and +3. And since that's darkened on the graph, they include them, right? So you're going to write it like an and. -3 is less than or equal to X is less than or equal to +3. If you don't see an open circle or a blank, if it's a broken part of the graph. So this is a solid circle, so it includes it.
So if it's broken, it's not gonna.
Yes. Yes. We'll see some in a little bit. Possibly. Okay, so for the range, the Y values are between this spot and this spot. Do y'all agree? Going up and down. What's this number? And this number is +3. And range are what values? Y value. So the range is -3 is less than or equal to Y is less than or equal to 3. So if you use a variable for domain, make sure you're using X. For range, make sure you're using Y. Okay, so this is saying our Y values are between -3 to +3 going up and down. Okay, all right. Number 3 is a continuous line, isn't it? It's a slanted line going down from left to right. So the X's are what? All real numbers because it's going left and right forever in both directions. All real numbers. What about the Y values? Yeah. As it's going left and right, it's also gradually going up and down in both directions. Right? Right? So a straight line, except for verticals and horizontals, are going to be all real numbers for both of them. Okay? So the range is also all real numbers because it's going out in both directions and going up and down for both directions. Do what? Oh, yeah. So that's just easy to remember. If it's a slated line, it's all real numbers for both of them. Okay. Do what? Because it stopped right here and then went back up. It didn't keep going down. Does that make sense? It kept going out, but it didn't keep going down. Does that make sense? All right, look at number 4. Does anybody know what the graph of number 4 is called? Starts with P. It looks like a peak of a mountain. Parabola. Raise your hand if you've heard of parabola. Well, you're going to hear about a lot of parabolas coming up in about March. And then I'm going to talk about parabolas for probably 2 months. All right? So this is a parabola. It's an upside down U-shaped graph. This one is. All right. So let's talk about the x's. It's going down forever, but it's also going out as it goes. So what do you think about the domain? It is all real numbers. Okay, so what do you think about the range? It's going down forever, but did it go up forever? No, it don't go past here, right? It stops here and goes back down. It never goes back up this way because it says it's going down forever right here. Y'all see that? So that's at 1, 2, 3, 4, 5. So do you think the y values are greater than or less than 5? They're below it. So it's going to be less than or equal to 5. So y is less than or equal to positive 5. Y'all see that? Any questions? How are we going to get good at these, y'all? Practice. That's why I'm showing you like a bazillion different kinds of graphs. Okay? So that way you have it in your notes. Hey, we saw one like that already in class. Right? Okay. This is some kind of, looks like a square that's turned sideways. No, it's a square that's turned sideways. There is no geometric shape called a diamond.
Wait. What's a baseball field?
It's a square.
No, it's not.
Yes, it is. It's a square. All right. But that's baseball. It's called a diamond because it's baseball. It's not geometry class, right?
But it's a diamond.
It looks like my diamond because my diamond is a square. But anyways. All right. So, because I'm pregnant. All right. So, left to right. Left to right. Is this going to be all real numbers for the domain? No. No, it's confined from here to here for the x's, right? Yep. What's this x value? What's this x value? 5. So your x is between -1 and 5, and it includes them. So the domain is -1 is less than or equal to x, less than or equal to positive 5. Is that okay with everybody for the domain? All right. The range, the y values, are they all real numbers? No. No, they're from this bottom corner to this top corner, right, of the domain. Okay? Okay? This is not geometry class, but I don't really have to speak geometry terms correctly, right? What's this y value? What's this y value? Positive 3. And remember, ranges are y's. So we say -3 is less than or equal to y is less than or equal to positive 3. All right, for you I'm a baseball fan, so I'll call the diamond for you guys.
Are you sure that was a banana?
Oh my gosh, y'all are killing me. All right. Number 6 looks like a cubic function, some kind of odd degree function. You'll see those in Algebra 2. All right, so domain. So you see how it's pointing down forever right here, and it does a little squiggle, and it goes up forever, right? But when it's going up and down, it's also going out, right? Okay, so what's my domain? All real numbers, I agree. What do you think the range is? The range up and down is also all real numbers. Very good. Because it's going out in both directions forever, so that's your domain. It's going up and down in both directions forever, so that's your range. We good? All right, turn to the next one. Woohoo! Okay, so this one, we count, hang on. 2, 4, 2, 3, 4, 5, 6, 7, 8. It looks like an 8th degree polynomial. Did we make a mess?
Yeah.
Go and get paper towels and don't interrupt my class because we're still having class. If drinks interrupt my class anymore, we will not be allowed to have them. All right, so domain, the x's, that's left to right. What are we doing left to right on this graph? We going forever?
Yes, ma'am.
So the domain is what? All real numbers. Okay. Do the ranges go up and down forever?
That's gonna be a lot of numbers.
No, it actually looks like they're stopping right here and right here. Y'all see that for the range? Y'all see that? So it's not really going up forever because it's bounded by these lines. Y'all see that? So what is this y value down here?
-3.
-3. What's this y value up there? +2. So my range is between -3 and +2. So -3 is less than or equal to y is less than or equal to +2. Is that okay?
Yes, ma'am.
All right. So number 8 is a sideways parabola. Y'all see that?
Yes, ma'am.
It's a parabola that we saw a U-shaped graph turned sideways. All right. So my domain, my x's, are they going forever left to right? Do I have anything going on over here? No, it don't start till you get right there, does it? So what's that x value? -1. And after -1, it does go forever, right? So what do you think we're going to call our domain? -1 is not a domain.
X greater than -1.
Not just greater than. Greater than or equal to -1. Does that make sense? Because the x's for this graph are greater than or equal to -1 from left to right. All right, so up and down, what's it doing? It's going to be going up and down forever, right? So the range is all real numbers. All real numbers. Okay. You don't see that vertical line? Trace over it if you can't see it on your paper. Number 9 is the vertical line right here. Yeah, it crosses the x-axis at 2. Say that?
X is greater than 2. No, that's
Okay, the x's. The x's. Are the x's going forever in both directions, left to right? No, they're staying right there, aren't they?
So would it be x is equal to?
Yes, it's just x equals 2. The x is always going to be 2 on that vertical line, isn't it? All of these, it's like, what's this point? 2, 0, 2, 1, 2, 5, right? 2, -2, right? The x's are all 2. So on that vertical line, x will always equal 2. What's the range doing? It's all real numbers. Very good. All. Well, not the exact opposite, but the opposite thing is happening, right? So in case you can't see it on your paper, your horizontal line right here, it crosses the y-axis at 1, 2, 3, 4, -4. So you might want to bold that on your paper if you can't see it. You can kind of see it with the arrows sticking out. So the domain, what's it doing left to right on that graph? It's going forever, so it's all real numbers for the domain. I can't write real. What about the range?
Is equal to -4.
Y equals -4 because the y is always -4. Does that make sense? So you're only going to use equals if you have a horizontal or vertical line. Does that make sense? Most of the time you're going to use an inequality symbol for a domain range. Okay? Good job. Okay, now we start seeing the open dots. You see that? I don't know if you can see it on your paper that good, but it's an open dot there. Do y'all see that? Okay. So that's going to change things just a little bit. All right? So domain, the x's, left to right, I'm between here and here. Do y'all agree?
Yes.
Okay. What is this x value?
-2.
And what's this x value? +5. So this one is included because it's colored in, right? This one is not included.
So it's not.
So you're going to put a less than or equal to sign for this one and just a less than sign for this one. Y'all see that? It's just a boundary, but not included. So we said, so -2 is included, so less than or equal to x, not included, so just less than +5 for the domain. Okay? Well, just give me a second. Is everybody okay with the domain?
Yes,
From here to here, but this one's not included, so you don't put the or equal to. Does that make sense?
Kind of like in the equations.
Exactly. All right. So for our range, our y values only go from here to here, don't they? Right? That's my highest y value and that's my lowest y value. Y'all agree? But this one again is not included, is it? So that one does not get an or equal to. So what's this y value? The y value is -2. And this is just less than y. And then it includes this one because it's solid on that part of the graph, less than or equal to +1. Does that make sense? So the x values went from here to here, and the y values went from here to here. This was an open circle, so we don't include those numbers. Does that make sense? Just takes practice, my friends. All right, on number 12, are all those dots solid? Okay, that makes it easier. So we're going to use or equal to's. Okay? So left to right, what's my lowest x value? X value. -4. Right? And this x value is the furthest to the right, which is 5. Now these don't have arrows, so they stop right here. Do y'all see that? Okay. So my x's are from -4 to +5, and they're included. So -4 is less than or equal to x is less than or equal to +5. Y'all see that for the domain?
Yes, ma'am. Will there ever be ones that are like, no.
Okay. You're probably going to ask something beyond the scope of this course. Right? Okay. And then remember, the range values go up and down. So I think this is my lowest point, and this is my highest point. Y'all agree?
Yes.
Oops, I hit something to the side. Go away. Yeah. Bloopers. Okay. So what's this y value down here? And what's this y value up here? And remember, these are y's. So it's going to be -3 is less than or equal to, because we're included, y less than or equal to +5. We kind of getting the hang. It's not bad, is it? Okay, 2 more of these. Okay, you can't see it on my screen very well, but this is an open circle, isn't it? Yep. Okay, y'all can see it better on your paper. All right. I think that's just a ray, isn't it? Okay, so this part of the x-axis is not, so it's just from here down. Y'all see that? That's a ray, okay? That is the correct geometry term for that. I promise. All right, so domain, does the x's go forever in both directions? No. No, it is to the left, but it stops right here, right? What is that y or that x value? 2. The x value is 2. So what do you think the domain's going to be?
It's less than 2.
It's less than or equal to?
Less than.
Yes, the x's are numbers that are less than 2. Very good. And does not include it, right? Because it's an open circle.
It just looks blurry.
Yeah, it's blurred on your paper, but on my screen you can see it a little bit better this time. Now, what about the y values? Do they go down, up and down forever?
No.
Right, it don't get above here. What's this y value?
0.
0. So what do you think the range is going to be?
Y is less than 0.
Is it less than or equal to? Less than. Very good. Okay. I want you guys to try number 14. And you see, okay, I don't know if you can see that, but that's the horizontal part of that graph. So it goes up, horizontal, and then up again. Y'all see that?
Yes, ma'am.
And that is a closed circle. So y'all try the domain and range on your own for that one, please. I think I'm still recording. Remember, domain is x's, range is y's. Yes, this is just practice. All right. We won't have a quiz on this till Monday. Monday.
So I guess that means we're not practice this week.
Very good. At least we got it. Now, does everyone see the area on top?
All right, y'all tell me, what do you think the domain is?
X is greater than or equal to negative 2.
X is greater than, and it includes it or equal to what number? -2, right? Because left to right, you're going from here over. Raise your hand if you got your domain right. Woohoo! What about your range?
Y is greater than or equal to negative 4.
Right, you're going from here up. And that y value is -4. So y is greater than or equal to -4. Raise your hand if you got your range right. Y'all, something very important, and I'm going to be picky about it because it's absolutely wrong if you don't do it. Domain has to have an X. Range has to have a Y unless it's all real numbers. Got it? Got it? Okay. So any questions about those? Let's talk about functions. It's one of my favorite things to talk about. And remind me to tell you a story after the lesson on functions. I might tell it to you tomorrow. I got a story to help you never forget functions. I have former students that are in college that remember about functions because of my little story. So I'll tell y'all later. I'll tell you later. All right. A function is, fill this in with me, a special relationship between values where each input, which is your x values, has exactly one output.
And the largest positive. So -118, -29, -36, -3 and 6 with the biggest part.
And like I said, I have a personal story to go along with this, but I'm not putting it on YouTube. So, bleh. I promise you won't forget what a function is. All right. So, for example, basically, for a function, if you want it like simple terms, x's don't repeat. Your y's can repeat, but your x's don't repeat. So you might want to highlight that because that's kind of simple form for that. So for example, if I have this relation right here, I'm zooming. 1, 2, -5, 0, and 3, 4. That is a function because all of my x values are different. Y'all see that? If each x value is different, then you have a function. Okay? For something that's not a function, like -1, 3, 0, -7, -1, 20. This is not a function because -1s are repeating for x's. The y's can repeat in a function, but your x's cannot repeat. Okay? So if you ever see a relation, which is just a set of ordered pairs, and the x's repeat, that it is not a function. If the x's are all different, then yes, it is a function. Okay? It's that simple. So if all the x's are different, you say yes, it's a function. If any of the x's repeat, it's not a function. You don't even look at the y's. Okay, they'll just confuse you. All right, just look at your x's. So that whole rest of that piece of paper on that sheet in your notes, that's what we're going to do. We're looking at x's. So number 1.
So that's all you have to do.
Yep, I'm looking at the x's. Are they all different?
No.
Yes. So yes, this is a function. You don't even look at the y's.
You just write function.
You can write yes or no.
So they have this circle.
You can write yes or no. Do what?
Do we circle?
Well, I'm just circling them so you see what I'm looking at. So number 2, my 2's repeat. So no is not a function, right? So if any x's repeat, it's not a function. So what do y'all think about number 3? My 3's repeat. My negative 3's repeat. So this one's not a function. What about number 4?
Yep.
1, 2, 3, 4, 5. All different. Yes, that's a function. That good? So number 5, they start putting them in tables, right? You just look down. I like this better. To me, it's easier to see, right? You just look down the x column. So do I have x's repeating on number 5? Yep, the 3's repeat. So what do I say for number 5? No. What about number 6? They're all different, so we say yes. Number 7. Yes, they're all different. So if the x's are all different, you say yes, it's a function. What about number 8? No, 4's repeat. Not a function. What about number 9? Look at all them y's. We don't look at y's, do we? No, you only focus on the x's, and the x's are all different. So yes, it's a function. You don't care what the y's are doing. Does it look like a positive 4 on top? There was a blur. Sorry about that. This is negative 4, that's positive 4. All right, what about number 10? Yes or no? Yes. Okay. So when you're looking at a mapping, yeah, you looking from the x to the y, the x's should only have one branch coming off of each. Does that make sense? If an x has 2 branches coming off, it's not a function. So what do you think about number 11? Yes. What about number 12? No, because that negative 1 has 2 branches. Does that make sense? What about number 15? Yes. Like I said, I have 2 arrows pointing to the 2, but you don't look at the y's, you look at the x's. So that one's a yes. So any questions about looking at a relation and telling if it's a function? Okay. So on the back page, which is the last page of our notes, I think, right? We're going to learn about telling if a graph is a function. Raise your hand if you've heard of the vertical line test before. All right. I think we learned about this in junior high or middle school. All right. So yeah, a vertical line test does just that. Okay? So if you're given a graph, if a vertical line, you can write this down. If a vertical line crosses the graph more than once, then it is not a function. So we call that failing the vertical line test. The vertical line, if you draw a vertical line anywhere on that graph and you're touching that graph more than once, then it is not a function. So an example, there's the x and y axis. Let me get a different color pen. And say I have a slanted line right here. That would be a function, right? Because anywhere I put a vertical line across my blue line, I would only touch it once, right? Okay. So an example that's not a function can be lots of things, actually. Could be like a circle. A circle, right? If I drop a vertical line on lots of places on that circle, I touch twice, right? So it fails the vertical line test. All right? Okay. So what we're going to do for the rest of those problems, 14 to 21, is we're going to do the vertical line test. And then if it passes it, we're going to say, yes, it's a function. Please stop talking. And if we say, no, it fails the vertical line test, then no, it's not a function. Okay? So when you have points, you want to see if any of them line up vertically. What do you think? Do any of these points line up vertically?
Yes.
Yeah, these two are failing the vertical line test right there. So this one is no, not a function. Y'all okay with that? What about number 15? Yeah, they all have different x values, don't they? So yes, that is a function. They're all different x's. They don't line up vertically. All right, number 16 is just a continuous slanted line, function or not a function? Yes, it is a function. It passes the vertical line test. Number 17 is a sideways parabola. What do you think? No, because if I drop a vertical like right here, I'm touching it in two places, so no, it's not a function, right? So if you can put a vertical line anywhere and it touches twice, it's not a function. We already said a circle is what? Not a function. So that one would be no. 19 looks like an absolute value equation. What do you think about this one? Well, if I put verticals here, I'm only touching once, once. No, you don't care about left and right. Vertical is a vertical line. So this one, yes, it is a function. Yes. The x values are all different. Number 20 is a vertical line. Does a vertical line pass a vertical line test? Well, what if I draw my vertical line on top of this vertical line? How many times am I touching? I'm touching infinite times. I'm touching too much, like some of you and your significant others. Right? So this one is not a function. All right? Okay. So, yeah, a vertical line is always going to fail a vertical line test. What about a horizontal line? Is that a function or not a function?
Yes, it's a vertical.
A horizontal line would be a function. So the only lines that are not functions are vertical lines. Got it? Slant lines are always functions, horizontal lines are always functions, but a vertical line is not a function. Okay? Number 20 is a good little, or 21 is a squiggle. Function or not a function? Yes, it is. So any questions on the vertical line test or anything we've talked about today? All right, that is the end of today's lesson. Have a good day. I'm ending my recording, I think. I've tried to do it where I could hide it, that way I'm not like tapping it.